The title of this talk is fairly long, but it's about cerium as a fuel additive, diesel fuel additive. So I'm really excited about this project for a couple of reasons. One is that it's first time Mike Hotel and I are really directly co-advising students, so I think we're getting some kind of interdisciplinary bang for the buck there. And second is that it really has potential to have an impact on us in the near future. So diesel exhaust, there was a report that came out last year that diesel exhaust is more deadly than car accidents. It's responsible for more deaths per year, premature deaths. It's not as bloody as a car accident, but nevertheless, it's tens of thousands of people in the United States per year, and hundreds of thousands, if not millions, worldwide. So there's a new product, nanotechnology-based product, cerium oxide, nanoparticles, that can drastically reduce emissions of soot particles from diesel engines by over 90% or so. It's shown here, it's made by a company called Envirox, or Energetics, and the product is called Envirox. So you would just add this to your tank, and then you get much lower emissions out. So it's been approved for use in the European Union. However, the EPA has not allowed it to be used commercially. And so the reason is that they're concerned about potential health and environmental impacts, which is a valid concern. Right now, there's not enough information out there to say definitively whether it's safe or not, but you also have to think about relative safety, because you think about those deaths that are caused by diesel particle emissions. Well, even if Ceria does have some small negative effects, maybe that would be much smaller than the negative effects of the diesel soot particles that are being emitted currently. So our goal, the overall goal here is to evaluate Ceria's potential for safe and sustainable use. We are looking at this overarching research question of what are the environmental and human health impacts of using nanoceria as a fuel-borne catalyst. So there's three specific questions that we're looking at. The composition of the commercially available fuel additive, which we had shipped over here from the United Kingdom, because you cannot buy it in this country. We are interested in what form of cerium is being released. There have been a lot of studies on how the cerium impacts emissions of regulated pollutants, such as particulate matter, nitrogen oxides, hydrocarbons. There have been very few studies on what actually happens to the cerium, which has to come out, has to go somewhere. And then finally, how much Ceria enters the environment. So we're going from a nanotechnology application, or nanotechnology kind of idea, to what is the real impact, potential for impact. So far, I should have mentioned, the student who's doing all this work is James Dale. He's an ICTAS scholar. And so far, he's gone ahead and characterized the fuel additive itself. So the nanoceria is suspended in this kind of hydrocarbon mixture, which will mix well with the diesel fuel. It's lots of alkanes, as you can see. This was just by GCMS, I imagine. And then he's done some electron microscopy characterization of the ceria itself and the additive. And here we're zooming in on that particle, which you can see has primary particle sizes of somewhere around roughly 5 nanometers, maybe even smaller than that. Looked at diffraction patterns and indeed confirmed that what we're seeing in the Envirox, the product, is very similar in terms of the diffraction pattern to what you would expect for cerium oxide. So we have 4 phases to our approach here. First of all, we've acquired a large diesel engine, the size that goes into a small tractor, and relevant other studies that have looked at generators use small ones that you would use to power a few light bulbs or so. And they're not turbocharged. Turbocharging, all engines on road are turbocharged, and that could potentially affect the characteristics of the cerium that's being emitted. So we're collecting samples of those and analyzing them. Then we'll be modeling what is the dispersion and then deposition going to be on the roadway adjacent to where it's being emitted. We will then be applying those cerium, that exhaust, to these mesocosms, which are kind of a mixture of an aquatic environment, and then there's sediment coming up that's exposed to the air. Plants growing in there, and there's organisms in there, and we want to see what the effects are on those, and finally looking at the toxicity. So we are in the process of getting our diesel engine up and running so that we can determine physical and chemical characteristics of ceria in the exhaust. So if you go down Plantation Road, the lab's there, and you see a little shed. Sometimes you might hear an engine running. You can stop by there and you'll see James running this and collecting samples, analyzing the particles that are being emitted. And we'll be then using deposition modeling with this. This is not what we've done, but it's a roadway running through a certain city, and you can predict what are the concentrations going to be at various distances away from the road. So we can then predict the amount of ceria that's going to be deposited near the roadways. We'll know the amount, we'll know its physical and chemical characteristics. And recent development here is that we did just get approval to go ahead and get 2 of these boxes, which are the so-called mesocosms, environmental or ecological mesocosms, down at Duke University, part of our SAINT project, where we will be dosing them with one with a cerium-treated exhaust and one with the kind of control exhaust where we did not have cerium in there. And then this is the kind of a schematic of that. And then we'll be collecting soil and water samples to see, okay, where's the cerium going and how water soluble is it? And then what effects is it having on the organisms that are in there? So this is showing, we'll be looking at plant uptake, and we're collaborating with Jason Unrein, who's an expert in this at the University of Kentucky. And then also the microbial population, in addition to probably other measures of toxicity. So finally, we want to have enough information so that we can help decision makers do this risk analysis of, on one side, I didn't mention that cerium also improves your fuel economy by about 10%. You can use 10% less of fuel, so you're going to get carbon benefits there too. So you have your fuel savings and your emission reductions on one side, and then right now we really don't have a good idea at all of what the impacts are. But we would like to provide the knowledge so that we can say something about those impacts. Is it going to be a net benefit or net loss to go ahead and add cerium to our fuel additive? And it does, again, have big potential impact in reducing the emissions of diesel particulates from those engines. So this is a summary of what we've accomplished so far. Publications are still in preparation, and I'd be happy to take any questions now.